when I'm saying that cataclysmic situations, natural disasters, they happen. That's the way nature is.
Yes, but you didn't have
You know,
mass extinctions for every ice
so
age
I just want to
because we're
understand, like,
talking about
to what level the climate crisis is due to human action and anthropological influence. Is it? Are we really in a crisis? Is it really a crisis?
So let me read you this thing, which looks like a website from the 1994. The Children's Museum of San Jose. When were the ice ages and why were they called that? The ice ages began 2.5 million years ago and lasted until 11,500 years ago. During this time, the Earth's climate repeatedly changed between very cold periods, during which glaciers covered parts of the world, see map below, and we have Antarctic, and very warm periods, during which many of the glaciers melted. The cold periods are called glacial, and the warm periods are called interglacials.
Interglacials, yeah.
There were at least 17 cycles between glacial and interglacial periods. The glacial periods lasted longer than the interglacial periods. The last glacial period began around 100,000 years ago and lasted until 25,000 years ago. Today, we are in a warm interglacial period. So we're saying that this ice age took 7,500 years estimate, because these are all estimates, to be generated. What if I told you if the same amount of change could happen in 100 years or 200 years? Would that be concerning for you? Something that naturally takes 75,000 years.
So we're accelerating those climate changes.
Yes. What is that going to mean?
Because of the levels of CO2 in the atmosphere?
Because of levels of greenhouse gases, CO2 being one of them. Yes.
Carbon dioxide.
That's
or no?
Yeah, CO2 is carbon dioxide. Like the greenhouse gases are.
No, wait. CO2 is not carbon dioxide, is it?
Yes. CO2, that's 2 oxygens, 1 carbon dioxide.
Okay.
So CO2 is
not a pollutant,
main...
right? CO2 is not a pollutant.
What do you mean it's not a pollutant? I mean, it depends on how much. Everything's a pollutant. Even you can die from too much oxygen. You have carbon dioxide, methane, and nitrous oxide, N2O, which is emitted during agricultural, land use, and industrial activities. You also have fluorinated gases, hydrofluorocarbons, perfluorocarbons, sulfur hexafluoride, and nitrogen trifluoride are synthetic, powerful greenhouse gases that are emitted from a variety of household, commercial, and industrial applications and processes. Fluorinated gases, especially hydrofluorocarbons, are sometimes used as substitutes for stratospheric ozone-depleting substances. Fluorinated gases are typically emitted in smaller quantities than other greenhouse gases, blah, blah, blah. Anyway, so these are the things to look out for. We have 79% of carbon, 11% methane, 7% oxide, and fluoride amounts for 3% of the U.S. greenhouse gas emissions in the year of 2020. So, yes, we talk mainly about carbon dioxide. And this is like a table of what emits. So the generation of power itself causes 31% of the U.S. emissions. Transportation, another 33%, right? So if you can fix these two, and there's a huge part of the transportation you cannot fix because you cannot make electric-powered planes, right? I don't think you can make electric-powered trains, and the trucking industry is still trailing behind the electric vehicle revolution. Then how you charge these correlates to how much electric power you have to burn, right? So you have, if you're gonna burn coal to make electricity, you're just shifting the problem. You're gonna get a lot less transportation.
Or if you're burning fossil fuel,
whichever,
to create electricity.
So the idea is also to be able to revolutionize the electric power grid, to be able to harness more sun power or wind power or tide power or all the kinds of renewables like hydro dam power.
Or start, tapping into nuclear power again.
Or nuclear power if you want to live with the potential chance of nuclear meltdown, which nuclear power is just a glorified steam engine. It's a fuel.
But I mean, I say like I know what I'm talking about.
So it's just moving water to get some rudders to move, to get a magnet to move around copper, and then you get an electric field, and then
keep investing in new new technology that
Then you have to
will
mine
allow.
this, like all of these forms of energy and all electronics, and everything needs to be mined for minerals and for metals, which make the whole world
I
work.
guess my the biggest question is, oh,
Yes.
wh- what should we do? Should we save water? Should we recycle? Should we, or all of the above? Like, what do I do?
Well,
Do I stop eating meat?
I would say
Like, what do I
we
do?
should be talking to
Meatless
we
Mondays?
should be we should be talked to by the experts, not as children, but like we need to spill out the facts. And the facts are you cannot get rid of carbon emissions. The experts say you can get to what they call a carbon neutral point, where the amount of output of carbon that you generate can be balanced or reach a point of equilibrium with the point that gets reabsorbed by nature, because nature absorbs carbon,
CO2, yeah.
right? CO2 is used by plants in photosynthesis and cellular breathing, and by all the vegetation on land, and both the equivalent in the sea, which I forget right now, the freaking kelp, and like all the little things that pump oxygen into the ocean.
But and also I've heard something about cycles that the sun goes through.
But those are
There there are cycles that have been
so
observed or
what?
studied. I don't know,
Yeah, so like this
and
the
and that is it is a
sun,
known thing that
and
the
but how does that
sun will go
affect?
in. It'll go into a colder cycle now, like for the next 100 years or something like that. So we will experience colder weather, something like that. I heard something like that in a podcast. I don't know. I'm just putting this idea out there.
Well, the almanac.com.
And I also heard that most of the climate oscillation, or the climate, the way the climate works is it's influenced by the sun, by the oceans, mostly by the volcanoes, by these very
So if there was no
the
volcanoes, you don't have no climate. Is that what?
no, I'm saying that, for example, it's affected much more by a volcano eruption, let's say, than what actual anthropological.
Well,
We've been
that's
talking for
why I
too long.
started by saying that.
Anthropological action, like it's is it human caused? Like what humans are caused are actually out of proportion, or is it like what's the actual impact compared to, let's say, the biggest active volcano in the world, when it erupts and releases all the insane amounts of CO2 into the atmosphere. Like I'm trying to I'm trying to go into a comparison scale.
Volcanoes can impact climate change. During major explosive eruptions, the amount of volcanic gas, aerosol droplets, and ash are injected into the stratosphere. Injected ash falls rapidly from the stratosphere, most of it removed within several days to weeks, and has little impact on climate change. But volcanic gases like sulfur dioxide can cause a global cooling. While,
Yeah, global cooling.
while
I heard.
volcanic carbon dioxide and greenhouse gas has a potential to promote global warming. So, in other words, a sulfur dioxide tends to reflect infrared radiation that comes from the sun, which is how we get our heat. And the volcanic carbon dioxide, a greenhouse gas, has the opposite effect, where the heat that comes inside the earth does not escape to the out of the earth, so it keeps the earth warm.
Why do we
The
always
most
tend to end up talking about climate?
I don't know. You just brought it up. The most significant climate impacts from volcanic injections into the stratosphere comes from the conversion of sulfur dioxide, which condenses rapidly in the stratosphere, blah, blah, blah. And the aerosols increase the reflection of radiation from the sun, which is what I just said. Several eruptions in the past century have caused a decline in the average temperature of the Earth, up to half a degree in the Fahrenheit scale. So it's like a quarter of a degree in Celsius.
Mhm.
For periods of 1 to 3 years, the climatic eruption of Mount Pinatubo in 1991 was one of the largest eruptions into the 20th century, and it injected 20 million ton in the metric scale of sulfur dioxide, so cooling gas, into the stratosphere at an altitude of more than 20 miles. The Pinatubo cloud was the largest sulfur dioxide cloud to ever be observed in the stratosphere since the beginning of the observation by satellites in 1978. It caused what is believed the largest aerosol disturbance in the stratosphere in the 20th century, though probably smaller than the disturbances from eruptions like Krakatoa in 1883 or Tambora in 1815. Consequently, it was a standout in the climate impact and cooled the Earth's surface for 3 years following the eruption. So, from these two examples, we
Wow.
can understand that the emission of volcanic eruptions sort of have a net negative effect. It means like it will cool the Earth more than it will heat because of the proportion of gases that are emitted from the eruption. The sulfates and the sulfuric stuff creates a reflection, a layer that reflects the sun's heat energy back into space. So it never travels into the Earth, or travels in less proportion. So that kind of destroys the idea that the volcanic eruption creates, based on these two accounts, of course, creates added heat trapping effect, right?
Right.
Do the Earth's volcano emit more CO2 than human activity? No. Carbon dioxide is a greenhouse gas that is primarily gas blamed for climate change, while sulfur dioxide releases in contemporary volcanic eruptions has occasionally caused detectable global cooling of the lower atmosphere. And carbon dioxide released in contemporary volcanic eruptions has never caused detectable global warming of the atmosphere. In 2010, human activities were
So it
responsible.
counterbalances climate
In a way,
global warming?
a big byproduct of these eruptions is the sulfur. I forget. I lost my-
Sulfuric.
Yeah, something. Sulfur dioxide. Deoxysulfuric.
Okay, interesting.
So the more we know. So now we know, if anything, at a net value, apparently, according to this one website called usgs.gov, suspicious.gov.
Everything's suspicious nowadays. Anything that is on the internet.
And so billion metric tons per year of gigatons, so metric
Hard
billion
to tell.
per year of global volcanic emissions. Highest preferred estimate is 0.26 anthropologic CO2 from fuel combustion, 32.3. So we're looking at, this is like a quarter. So a quarter relationship to 1, where it's like 120 times or more emissions from fuel burning than from yearly emissions. Worldwide road transportation have approximately megawatts of coal-fired. See, not even like, well, I don't know how many 1,000 megawatt coal-fired power stations you would need to power the world, but even the country of Argentina, I don't know where this estimates come from, but taking them at face value, we see a lot of consumption in the combustion of fossil fuels. Hello everybody, and thank you for watching until the end. This has been Woke Wars, and I hope you liked our conversation. Don't forget to hit that like button and subscribe, and drop a comment down below. Tell us what you'd like to hear us talk about next. Also, check out some of our other episodes. We post every Wednesday, Friday, Saturday, and Sunday. We will see you on the next one.